Hello everyone. In this video, we will learn about probability, that we will understand what do we mean by probability, what are its basic concepts, and how do we find the probability. Okay, so to understand probability, first we should understand some of the fundamentals. So one of them is like sample space. Now, what do we mean by sample space? Sample space is nothing but the set of all possible outcomes of an experiment. Okay, so this is how we define a sample space. For instance, if a coin is tossed and it is asked to write the sample space, then what it will be. So when we toss a coin, we know that coin is having two sides. Okay, so one side we will see a number and on another side we'll see a picture. So let's call the side on which we are getting number as head and the side on which we are getting picture or image as tail. In short, we will write H or tail. So what is possible? When we toss a coin, either we get a number side or we get a tail side. So these are only two possibilities. So by definition, sample space is collection of all possible outcomes. So in this case, we say that the possible outcomes are head or tail. So the sample space is head, comma, tail. This is how we write. We write sample space, we denote it by capital S equal. Under parenthesis, we list out all the outcomes separated by a comma. Like here, the outcome was head, comma, tail. Okay, and if we are using the short notation H or T to represent head and tail, in this case the sample space become H comma T. Okay, so we have here two possible outcomes. Okay, so let's move to the next example. If it is asked, write the sample space for tossing a dice. Do you know what is dice? Yeah, dice is a this figure with six faces having numbers from 1 to 6. So, what happened here when you toss a dice? You get any of the numbers, right? You get either 1, 2, 3, 4, 5, or 6. Do you have any other possibility? No. So, we say that the possible outcomes are getting a number 1, number 2, number 3, number 4, number 5, or number 6. Since it contains numbers from 1 to 6, we'll not get any other number. So in this case, we write the sample space as all these numbers 1, 2, 3, 4, 5, and 6 separated by a comma. So this is your sample space. I hope it's clear now. Okay, so moving on to next example. Two coins are tossed. We have to write the sample space. So in this example, we have two coins. Okay, two coins. So if you remember, we when we toss a coin, we get either head or tail. Now we are tossing two coins. So let's say we write down the output of first tossing first coin and here the second coin. So when we toss first coin, what is possibility? First coin shows head. And what is the possibility for second coin? That it also shows head. Okay. What is other possibility? It's like the first coin will show head and the second coin shows tail. Okay. Any other thing possible? No. Getting first head on first coin. These are the only two possibility. Now what is possible is on first coin we get tail and then we get head on the second coin and for the first coin we get tail and we get tail on the second coin as well. Do you think any other possibility here? No. So in this case, what will be the outcomes? we get head on both coins. We write it as HH. We get H on the first coin, tail on the second coin. Or we get tail on the first coin, head on the second coin. So we say it as TH as a possibility. And both coins show tail. So these are the only possible outcomes. So in this case, this is your sample space. It is having 4 possible outcomes. Okay, so in this way, we will write the sample space. So you can write the sample space as this. Okay, now we define the probability. Now, what do we mean by probability? Probability is how likely something is going to happen. Okay, like how likely it's going to rain. This is how we get the weather forecast, or how likely you are going to watch this video. Okay, so that's the probability. Now, when it comes mathematically, we do have a formula for it. So, the probability of any event A happening is given by, we denote it as probability of A. P stands for probability of event A. In short, we write P of A. It is defined as number of outcomes which are favorable to event A divided by total number of possible outcomes. Okay, and probability is having a property that the value of probability always lies between 0 and 1, and sum of all probabilities is always equal to 1. So these are two things you should know. Okay, now let's consider an example. A coin is tossed once. This is your experiment, tossing a coin. Okay, now what they are asking, find the probability of getting a head. So this is your event. Let me name as A. Okay, and the second part they asking, what is the probability of getting tail? So this is again your event. Okay, so let's say event B. So to find these probabilities, always first start by finding sample space. So when a coin is tossed, you will get either head or tail. So what is the sample space? H, comma, tail. This is sample space. How many outcomes are there? 2 outcomes. Either head or tail. Head is first outcome, tail is the other outcome. Okay. Now, what they want, what is the probability of getting head? So how many times you see head? What is the probability of getting head? H, right? So we write probability of getting a head is number of times head appears divided by total number of possible outcomes. So probability of getting head. How many times head appear? Only one time. So it is 1 divide. How many total outcomes are there? 2. Okay. Since head, it is only one outcome. Similarly, if we ask probability of getting tail. So how many times you see here tail? Only one time. So one outcome. So you have to find out the outcome from the sample space. So head is appearing one time, tail is appearing one time. So probability of getting a tail is number of times tail appears divided by total number of possible outcomes, which is again 1 over 2. So here you see that if I say this is probability of A, probability of B. Okay, I denoted event A by head and event B by getting a tail. So you say that probability of A is greater than 0. It lies between 0 and 1. Same as probability of B. Also, if you add both probabilities, what you get? 1 by 2 plus 1 by 2, which is 1. Okay, so the property of probability that I told you earlier, it satisfied here. Okay, Let's move to the next example. A dice is thrown once. What is the probability of each outcome? So dice. Again, it's a dice is this, and the possible outcomes you can see the numbers 1, 2, 3, 4, 5, 6. So what you write the sample space here? Numbers from 1 to 6. So how many outcomes are there? 6 outcomes. Okay. Now, what they want? What is the probability of each outcome? It means they want what is probability of getting the number 1. So how many times you see 1 here? This is only 1. So output is only 1. So 1 over how many total? 6. Okay. So 1 appear 1. How many? What is the output? Only this. No. If they ask you how many times the number 2 appears, it's only 2. So probability of getting 2 is again 1 over 6. It's simple to understand. These are 6 outcomes 1, 2, 3, 4, 5, 6. Out of which, how many times you see 1? This is the only option over total 6. Okay. Similarly, if I ask you what is probability of getting 6, is again one side out of 6. So that's why probability of each outcome will be 1 over 6. Probability of getting 4 is again 1 over 6, and probability of getting 5 is also 1 over 6. Probability of getting 6 is also 1 over 6. If you see probability of getting 1, 2, if you add all of them till probability of getting 6, what you get? 1 over 6, 1 over 6, 1 over 6. How many times? 6 times. So this gives you 6 over 6, that is 1. So sum of probability is 1. And all probabilities are greater than 1 over 6.